Greetings of the day. My name is Sheik Jamil Ahmed. I am from the Department of Data Science, and the topic for today is machine learning and its workflow. Let us see what are the content that we are going to cover today. Like, I'll give you the short introduction about what is machine learning, then what is the machine learning workflow, then the problem definition, okay, data, what is data, and what are the different type of data, evaluation, features, modeling, and experiment. So I'll just put a discussion on the steps that is there in the machine learning workflow. Now, there is a there is a buzzword in the current scenario, like what is machine learning, okay? And you must have seen that there are a lot of companies who are giving training on machine learning. Students in the final year and pre-final year, they're doing projects on machine learning. So what exactly is machine learning, okay? So machine learning can be, you can divide into two parts. Like, it is the ability for the machine to learn, okay? So a user, a human, is providing an ability for the machine to learn something, okay? It can be a pattern in your data set. It can be, trying to find out the features of a image of a dog or cat, and then trying to classify whether a given image is that of a cat and dog, okay? So the first thing is that the human being is providing the ability for the machine to learn, and the second part is that without human intervention. So once the machine understand the pattern, here the human intervention is not required, okay? So there is a, like, for example, you can see in the slide that you have data, okay? You have data, and you are providing to the machine learning algorithm, and your machine learning algorithm is doing what? It is finding the, the relationship of the features inside the data and finding the pattern of the data, okay? And then once it knows the pattern, the model, if you give any new data in the model, or we can say the algorithm, it will give you the more pattern. It will understand, give you the output, okay? For example, you're a bank manager and you have a, loan data set. And what you need to do, you have to decide that if a new customer comes, whether you can give him a loan or not. So based on your last 5 years data set, what you can do is that you form a pattern and you can find out, okay, certain, people of certain age and gender and, their income limit, okay, whether they own a household and all that or not. So, so these type of people are, paying the loan or not paying the loan. So once you understand that, pattern, you can apply to any new, customers who are applying for the loan and decide. Okay, so this is one of the example of your, machine learning algorithms, okay? So let us see the workflow that we are having. So first, we are going to have our, uh, you know data collection, that normally people say, and that is true also. Like, if you want to do a research or you want to do work on machine learning projects, you have to spend some 60 to 80% time on data collection. Remaining 20% time will be on your workflow, okay? So data collection is, can, again, I can say that it can be of two type. Like, it can be, primary and secondary. Primary means where you collect your data yourself, okay? Like, for example, you want to find out what is the pollution of in Bangalore, or you need to find out, how much traffic is there in Bangalore. In that case, you collect the data yourself and do the research on that. That's a primary data set. Secondary is that when you collect the data, which is, you work on the data which is collected by someone else. Like, for example, you collect from Kaggle, okay, or you can go to UCI machine learning repository and or GitHub, and you can, work on that. That is a secondary data set. So data set which is collected by someone else, that is a secondary data set. So the first thing, once we collect the data, and then what we do is that we go for data modeling. Now data modeling has got 6 steps, okay? So that is a major concern of this lecture, like to understand the workflow of a machine learning project. So first is that the problem definition, okay? Like, what problem are we trying to solve? So that is the first step. The second step is that, what is the data? What data do we have to solve that problem? Then, if you want to solve the problem, you need to find out whether the problem is solved to what success rate. Okay, so we have to very clearly define the evaluation. Okay, and then that metric has to be given. Now based on the problem also, we can say what type of metric we are going to use it. Okay, then we can go for feature, understanding the feature, what feature you know should we model. So normally feature, if I say in a very simple term, if you have an Excel file or CSV file, every column is a feature. Okay, or it's called a variable. Another name for feature is called variable. Okay, and the feature can be many, but what feature is giving you the good accuracy. Okay, and which features are not required. Okay, so this you need to understand. So the very important thing is that if you understand your data set very clearly, most of your problem is solved. Then we have something called modeling. Okay, so what kind of model? So model can be, you can say it's an algorithm, is an estimate. Okay, what type of model are you going to use? That also depends on your data. Okay, whether it's like, because then we see there are different type of data like supervised, unsupervised, semi supervised, and reinforcement learning and all that. So you have to understand, okay, for a particular type of problem, we can use these algorithms. Okay, whether it's a classification problem or it's a regression problem, this has to be very much clear, and based on that, there are algorithms we can use it. And once you get the model and you apply it, okay, you can do some experimentation, like you can make your baseline model and then you improve on the hyperparameters, and you can increase one hyperparameter, two hyperparameters, three hyperparameters, and see the accuracy. And this is a very iterative process. Like, okay, you understand, okay, the first experiment is giving you a certain accuracy level, a certain success rate. Then can we improve that? Okay, so then you need to go and check out with your problem definition, and then again you need to traverse the path for the uh, this one machine learning workflow. Okay, now let us have a discussion on each one of them, one by one. Now problem definition. So they are you need to have a very clear picture, like what type of problem are we solving. Now, I have given only two types. Majority of the author in the machine learning book, you will find it four types. So let us just stick to the first two type. One is a supervised learning. Okay, one is a supervised learning, and the second one is a unsupervised learning. So what type of problem is a supervised learning? Supervised learning are those data set or those type of problem which has a target variable or which has a label data. Label data means, for example, if I'm collecting a CSV file where I need to find out whether a person is having a heart disease or not, then the column which is telling person is having a heart disease, yes or no, this is called a label data or target variable. So any target variable, data set is having a target variable, that is coming under the supervised learning. And if the target variable or the label data is not there, we say that type of problem is unsupervised learning. So depending on the type of your problem, you have different type of algorithm. Now supervised learning has got again two major part, like you have got classification and regression. Okay, so you can see on the right hand side there is a classification of whether a person is having a heart disease or not. In the classification type of problem, your label data are categorical. Okay, like for example, it has got discrete values like yes or no, 0 and 1. Okay, so this type of problem are coming under classification. Smoker, yes or no, whether the person is a smoker, yes or no. So if your label data is categorical, it is coming under classification. And there is another type of problem in the supervised learning is regression. Now in regression, what happens? You have a label data which are numerical. For example, trying to find out what is the cost of a house in Hebbal in Bangalore in 2030. Okay, so trying to predict the price. Okay, that will come under regression problem. Okay, what is the stock price, okay, in the next day, or you can say what is the price of the house. Okay, all this, when your label data is numerical in nature, okay, then that type of problem is called regression. Okay, I hope it is clear. Now next we come across the problem statement is done. The second part of a machine learning workflow is data. Okay, because based on the data we will apply the algorithms. Okay, and also evaluation metric and all this. So now your data can be structured, like for example, we are trying to get the uh, information about the students. So we'll have what we have, the roll number, student name, okay, mobile number, gender, and all this. Okay, so when your data is in a form of a row and column, like in Excel and all that, Excel, CSV file, these are called structured data. These are called structured data. And when you have, unstructured data is what? When the data doesn't be, you cannot put it in the form of row and columns, okay, a certain pattern, it is called unstructured data. So the example of your video, audio, your image, okay, and also your this one text files, these are all coming under, though text is coming under semi supervised, okay, and that is coming under structured, unstructured. So video, audio, these are coming under unstructured data, because you cannot form a pattern. So these two type of data set, you have to solve different, take a different approach to solve it, and different algorithms are there to solve these problems. Next, we come to evaluation. So now, how can you say that, okay, I made a model, okay, I have a data set, I have a problem statement, whether I'm success or not, okay? So, there's one example here. If you see the diagram, there is a house data which is having the house price, and one is the actual price of the house, and one price the model is predicting, okay? One of the price the model is predicting, that is, you can see the actual price is $500,000, uh, and this is 4,97,890 dollar, right? So here you can see that the predicted price is less than the actual price, but very close to it. Okay, so this shows that how much there is a error. Okay, how much there is a error between the actual price and the predicted price. Okay, so this shows the success rate of our evaluation. So the more the value predicted by the model is close to the actual price, okay, less is the error. Okay, and one more thing is that, because see, this is the regression problem, so the metrics for this will be different. For example, if you're talking about the classification problem, like when you want to classify whether this is the image of a cat or dog, and there's a man or woman, okay, so heart disease or not a heart disease, in those cases your metric will be like accuracy, F1 score, recall, precision, and all this. But when you talk about regression type of problem, your metric will be, mean squared error, RMSE, okay, R square, and all this stuff. Okay, so evaluation, depends on the type of data that you are, problem statement that you're working with. Okay, next we come across the fourth, step in a machine learning workflow, is that the features. Okay, so the features are, what do we already know about the data? This is a very important thing, because if you don't understand your data, if you don't have an insight about your data, you cannot solve your problem. Okay, so there is an example of, there is a heart disease, okay, where there is ID, weight, gender, and you have blood pressure, and you have the chest pain value, and then the last one, that is a heart disease, which is yes or no. This is a categorical data set. Sorry, it's a label data. So there is a label, which is also called a target variable. Okay, so now you need to understand, out of all these features, now which is the feature? This ID is a feature, weight is a feature, sex is a feature. Okay, blood pressure, chest pain, all these are called features. Okay, in other words, I can say these are called, also called variables. Okay, or you can say the column name and all that. In a very layman approach, you can say it's a column name. So features is a very technical term. So now, out of all these, feature, which features are very important to predict the target? Target means I'm talking about the heart disease. For example, you can see that weight of a person is a very important feature, which can denote that, okay, the person can have heart disease or not. Similarly, blood pressure can also be a part of it. But ID of a person doesn't have any effect on whether a person will have a heart disease or not. Okay, clear? Similarly, chest pain level, that value will also have an effect. Okay, but there is also something called feature importance. Maybe one of the feature is having more effect on the output than the other. Okay, so this understanding, this your feature is a very important step in solving the problem. So you might start writing the code and see the data, but while working, you will know that you got stuck, and you need to again start from square one, your level one, and you have to understand your data and the features, and then go ahead. Now let us see the step 5 of my ML workflow, that is modeling. Now, based on our problem and data, what model should we use? This is very important. This is very important because see, if we have a structured data, then we can use certain algorithms which are we are calling model 1. Okay, but if you have problem to unstructured data, we have to use different type of algorithms. So modeling also depends. Like for example, again, there also, like for example, if you have got classification, you have different algorithm for classification. If you have regression problem, you have different algorithm for regression as well. Okay. Whereas if you have got images and videos and audios, then it's better to use neural network, which is in deep learning. Okay. So there the algorithms are different, like CNN, RNN, okay, autoencoder. Then you can use transformers and attentions and all this. Okay. So that is quite different set. So what you can understand that we cannot proceed, even 1 inch, okay, without understanding the problem and the data. That is very important. Okay. Let's go for the next one, which is the last one. And also one of the most important, if you do a research, you need to keep on doing experimentation and experimentation, and you have to keep on, checking out your accuracy and your, precision and all this. So the first question that should come in your mind is that how could we improve? Okay. Or what can we try next? Okay. Now suppose, you have your first attempt with your data. Okay. And it doesn't work out, or you did not understand the problem statement itself, you go for the second attempt, try to understand the problem. Okay, collect your data, understand the data, and then if you are not failing to create a matrix, evaluation matrix, then again you go for the next step, where you understand all these 6 steps, like you have your problem statement and your data, and improve on your work on your metrics, and you work on your features and the modeling, and you do the experiment. Okay, and like for example, in the experimentation, what is being done, you take a very simple model first, and that is called a baseline model. You get the accuracy, then you can work on that algorithm by tuning the hyperparameters. Okay, and checking out the accuracy, and running the your code for a certain number of epochs. Okay, clear? And checking out your uh, with different algorithms. Okay, so when we try different type of algorithm, a combination of them, and find out which is giving me the best accuracy, and this is a very iterative process. Okay, so I have covered all the 6 important steps for machine learning workflow. These are the references that I'm having. Okay, and thank you uh, for this for this lecture. I hope you have understood what is machine learning and what is a workflow that we have for machine learning. Okay, so it's a one thing I can say, that you have to keep on learning. Okay, there are a lot of algorithms, and the most important thing is that you have to do your hand dirty. You have to the more you do coding, the more you understand, learn theory, do problem. Like for example, if you are doing KNN algorithm, okay, understand the theory, do one problem, do the coding, and then you implement one project. Okay, so your learning will be complete when you do the project. I hope you have got the ML workflow, and you can start your path towards the machine learning projects and research. Thank you very much for this for for this for your time, and also understanding the concept.